In this video, we're going to discuss an interesting class. It's called BigDecimal, which essentially wraps itself around the double data type, but it allows to control the way we round fractional numbers. So the double type isn't flexible enough to provide control over how the number is rounded, and basically this rounding kind of like happens in the hardware itself. So we cannot we don't have much control over that rounding, and it's always rounding numbers up. For instance, if you have a fraction which is greater than 0.5, it will, or equal 0.5, it will always round up. But if it's less than 0.5, it will be rounding double. So when working with currencies, double types, especially when we have to deal with dollar amounts, often yield rounding errors. This really happens over large volumes of data. When you have, for instance, hundreds or thousands of sales or invoices or contracts where these dollars and cents are specified, and you keep adding them together in the simplest way. Sometimes you have to compute taxes, sometimes you have to apply certain discount rates, and there you're faced with the challenge to again round and round and round to dollars and cents as a result of your computations. So over time, over a large amount of transactions or items that you have to compute, the rounding errors just keep adding up to and become really significantly visible numbers. So here we have a BigDecimal class that gives the programmer a control over rounding behavior of floating point numbers. So this deals with fractional numbers. This has nothing to do with integers. And there are as many as 8 different rounding modes, which we will see in our presentation here. So just a quick example that would be interesting thing to consider. So if you have an ice cream that costs $10, okay, so that's just pretty good start here, but the sales tax is this rate. So what we do is that we take the dollar amount multiplied by this tax rate, and this is the amount of taxes that we have to pay. But we really sort of like because this is all based on individual sales and exact dollars and cents that were exchanging hands, we just have to come up with the decision to store only dollars and cents. Really oftentimes there is no place to store this extra precision, so we have to round. So the double data type would round up, because 8 to 5 rounded up is 0.83. Okay, so this is the representation of the rounding operation. And it's okay. This is all we learn in school. This is how we do most of the time. This is how we round numbers when we have to do that, right? So, but the total, if we add 10 plus this, becomes 10.83. So there, the tax collector would get this, okay? So there's like extra something that we give to the tax collector here. So now if we multiply this by a volume of 1,000 items sold, you just multiply this and keep multiplying what we pay to the in the amount of taxes, and it may amount as now there's like whole dollars amount, and so this becomes a significant issue. Okay. So I hope you see that this is something really to consider when you're writing software that handles financial calculations like we discuss in this example. So this is a BigDecimal class exists there. So if we take this BigDecimal, if we want to use this BigDecimal, okay, and I'll just name it BigDecimal. Right, that's the name of the local variable, and because this is an object, I will create it we'll see how we create it. But for now, if I want to fix the imports, right, it shows me that there's a math library in addition to the language library, and BigDecimal is part of that specific package. So you do need import statement for BigDecimal, like we indicate here. So the common methods of BigDecimal. Once you construct this BigDecimal and you have this BigDecimal encapsulating your number, you will be able to add, divide, multiply, subtract. All the basic math operations are here, and you also can set the scale for rounding. By the way, division also needs the rounding mode. We'll see that in some of our examples. So now, instead of using pluses and minuses, you have to rely on the methods that come with BigDecimal. So rounding modes and the scale. So the rounding mode is simply a set of constant values, such as half up or half even, and this is most commonly used rounding scheme, half up, which is built into the double primitive data type. But this is what we call a banker's rounding, often used in the USA to construct financial software. So for instance, if we have this value BigDecimal, we can set the scale. This specifies how many significant digits you want after the decimal point, and this is the type of your rounding that you want. So don't worry, we'll see some examples of this. So if we do set this BigDecimal equals new BigDecimal and construct it from, as in this example, from 4.5 value like this. Okay, so in that case, if we set the scale, so right here my BigDecimal, and I want to say set scale, and I want to round to the whole number. Okay, so basically the scale will be set to 0, which means don't give me any digits after the decimal point. I just want the whole number. And here we specify the rounding mode. So I'll just try this example as we have it without any modifications, like this. Okay, and there is also, by the way, this needs to be also fixed because there's the rounding mode that needs to be exported right here. This is a set of constants that come with all sorts of rounding modes that are available inside this set of constants. And the very important thing is that when you do something like this, when you create a decimal number and then you change something in it, this original BigDecimal is immutable, just like strings are. So you must remember to do this. It's very tricky, by the way. You just have to remember to know that set scale changes something in this original object, and you need to reassign it. So basically, to demonstrate right now what we have done, I'll just insert a space right here. And to illustrate, when we, of course, the new operator allocates space in memory and creates this object and populates its data attributes with this specific value that we took out of this example. So then when we so right here, this is a reference to an object, and this object exists somewhere in memory right here. Okay, and it contains the internally it contains this number 4.5 because that's what we wanted. So this is fine. But when we want to change something and we say, now we want to drop all fractional numbers from it and use this type of rounding, this object is constant. You cannot change it. That's by definition, by the design of this BigDecimal class. And setScale, instead of updating this, makes a copy of it. Okay, so this setScale makes a copy of it just like this. Okay, and of course you already said that you want no fractional numbers right here, and you want to round it at this stage. So it will become 4.0, but notice that the object is new. It just, like, this method makes a copy of this object of itself and makes it a new object with a change. So this is why, of course, this is the same reference, right? So I'll just use it right here, that we change reference to this. And this reference is now gone. We totally disconnected from here. So this object will be destroyed by Java garbage collector. This now has changed to the new set of values, and according to this new idea, the way we want this to store the information. So of course, just like if we for a second switch back to this slide right here, if the discarded fraction, which is this fraction right here, is greater than 0.5 or equal, and that's where the rounding errors are happening, by the way, then round up. So 4.5 will become 5. Okay. And of course, if it's less, for instance, if it's 1.1, it will be rounded down. So 0 parameter sets the precision scale to 0 decimal points. So this is very simple. This number right here, this 0, essentially tells how many of the fractional numbers to keep, which can be 0, which means that we don't want any.